Hey guys, so we are going to be working on Isogram. Let's have a quick look at what we've done so far. Awesome. So we have made some good progress. So I have started looking into this isogram. So let's go ahead and have a look. So we are looking for words that don't have any phrases repeating. So letters, spaces and hyphens are allowed to repeat. So we have this word here, for example, the word isogram is not an isogram because it repeats the letter S. All right, so to solve this one, I was thinking of a way of extracting all the accepted things like spaces and hyphen dashes. So let's have a look and see what the test is looking for. So scan through this, we have dashes in there, we have uppercase letters. So let me have a look at this 11. So it's repeating E a few times. So in here, create a variable. So actually, in we could use regular expression. I'm going to have a look here, look for something a bit more difficult. Anything with a dash maybe would do. Let's take 6-year-old. Let's take this one. So this has dashes in it. So I'm trying to see how can we get rid of the dashes. All right, so now I had a quick look at the regular expression. I think I'm going to make a completely new blog where we go over new tutorials where we go over all these different symbols for regular expression. It could be a bit scary when you look at them initially, but when you break them down, it's quite straightforward. All right, so what we could do, one of the ways to do this is to use regular expression. And we can say to substitute all the non-alphabet, right, with nothing. All right, so that would give us 6-year-old without the dashes, for example. All right, but that's just one way of doing it. But I will cover more of this in a very different tutorial where we can spend more time learning about regular expressions. But there is alpha method where we can say loop over our string and check if it's an alphabet basically. All right, and return those alphabets. So that's again going to skip things like the dashes and everything else. Then we have to take care of the things that are capital case, right? So we can use the lower method of string. So before we return this, we could basically say lower, and that will make sure that it's in a lowercase. Now looking at this, I think we can probably use that in our solution. All right, so I can have another look at a method called set. Well, set is a data structure that we've come across a few times, but the really cool thing about set is that is unique. Okay, so the elements have to be unique. You cannot have a duplicate in it, unlike a list which can have duplicates. So to use that, I was thinking if we create a set that has duplicates, what does it do? In that case, it only shows us things that are unique. So that means that I can create a list and I can create a set and I can compare them. So if I had this two here, which is exactly the same, all right, and I said, give me the length of this list and give me the length of this list, and it's identical. But if I said, give me the length of the set, if it wasn't, then it will be false because we know set removes duplicates. So we could use that in our solution. And to see that in action, I can have a look at alphabet. So I create an alphabet, and I can check if the length of that is the same as the length of that. Oops, I was expecting false. So string, I've used a as my variable, it should be s instead. So if I change that to s and run it, so there we go. Alright, so that could be our solution. So let's try and run that and see if that works. So I'm just going to copy over that. Alright, so I'll substitute s for string, and that would give us something. Not quite there yet, so this will loop over and give us a x in lowercase. So that basically gives us our new string. So I could just put this as string. So now we want to go ahead and do the comparison using list and set, knowing that set will remove duplicates. So if I check the length of this set against the length of the list, all right, so if I return that, it will be true or false. So that should have that problem solved. All right, so that alpha is doing the trick for us, and then we can compare that to that. Okay, so let's have a look and see. PyTest, and it's all green. Okay, so that worked. So we can safely say that we've solved this problem. All right, so let's go ahead and push this up. Okay, now and let's view our community work. So this one here, okay, this is going over all of them and then manually checking if it's empty or score. If it is, it continues. Checks if it's in the counter. Okay, so it's manually doing the work there. So this is also doing something similar and then checking. I need to check that method and then incrementing alpha and then compares the length and some very similar, returns true or false. So this is okay, checking for string.lower. That's actually better than what we did. You should check it ahead, and then it does some manual work, which we shouldn't really, because we can use better methods there. But checking for the string before doing the computation is actually smarter. So this is also like perfect. It uses filter, which is a really good method. I researched that method afterwards. It's really, really good. So to me, this is probably like the best one. So it uses the len and set as well. So that's awesome. All right, guys. So that's it for this one. Check out other ones. Learn any new method that you haven't come across. Just check it out and learn from that. So we are making progress. So we have this one here, and it's a medium. So we've been looking at easy ones. So I'm looking forward to seeing what a medium is like. All right, guys. So that's it for this one. We are making good progress, and I will see you in the next challenge.